Hi, this is SmartSafe from Group 21. Our team members are
Eric, electrical engineering major.
Nick, computer engineering major.
myself, Alexis, electrical engineering major, and Lakshmi, our computer engineering major. SmartSafe is a compact enclosure to store and secure valuable items like passports, jewelry, or firearms. Our design will implement a convenient keyless multi-access system. Users will receive real-time alerts for unauthorized access attempts or sensed tampering.
Some expected functionalities of our safe are authentication through fingerprint scanner keypad. The solenoid lock activates upon correct input. 30-minute lockdown after 4 incorrect attempts. An email notification when the safe is accessed or its status is changed. An email alert if tampering or motion is detected, enhancing security.
In this demo, we are first going to go over the hardware and software components used within SmartSafe. Then we're going through a few scenarios where some of the main features are going to be used to show overall functionality. Finally, we're going to go through our 3 demonstratable engineering specifications.
This is our component overview of SmartSafe.
So our main PCB is connected to our keypad, fingerprint scanner, motion sensor, LED and buzzer, our display, and our door sensor, as you can obviously see right here.
Our locking mechanism connects to our solenoid, relay, transistor, and voltage regulator. Both PCBs are connected to our power supply, which also acts as our battery backup system. The first PCB uses 5 volts through dew point wires. The second PCB connects through 9 volts through a DC power jack.
SmartSafe website. Here we have a list of email notifications the user can expect to receive from our safe. Here we have our contact info in case the user wishes to contact us. Here is a box for the user to enter their email. After they're entering their email, they can press the submit button. Then they will get a thank you message confirming they have submitted their email. Now they can expect to receive a confirmation email in their Gmail inbox.
In this scenario, the user will enter the correct passcode at this given time. An email will be sent to the owner of the safe that it's been accessed.
In this scenario, a user will place their registered fingerprint onto the scanner. When the safe is unlocked, an email notification will be sent. In this scenario, when 4 incorrect passcode attempts are made, lockdown mode will be engaged. Incorrect passcode attempt 1, second incorrect attempt, third incorrect attempt, fourth incorrect attempt. Oop. And lockdown mode is engaged. Not only will the user receive an email saying that lockdown mode has been engaged, but only a registered fingerprint can be used to access the safe and disengage lockdown mode. In this scenario, this is what happens when someone approaches close enough to the safe to be able to interact with it. As you can see, the time is 9:31. That means the motion detected email will be sent.
In this scenario, we implemented a tamper detection as a stretch goal. Once someone tries to access the safe without the passcode, the owner will receive an email alert, the LED will turn red, and a buzzer will turn on.
Ow, what's that? I'm getting robbed! Oh no!
In this scenario, the owner of the safe will receive an email alert to close the door when left open.
Alright, in this scenario, we're going to go over how to enroll your fingerprint when your fingerprint is not enrolled in the safe already. Currently, my ring finger is not enrolled, as you can see. So we're going to enroll it by pressing the A button, and it will ask for a master code to enroll your fingerprint. In this case, it is 10, 10, 10. Master code is approved, and now you must enter what ID number you must have your fingerprint enrolled under. I will enroll it under 100. It is a valid ID, and now we will start the process. Ask me to remove my finger, place the same finger back on. The enrollment is complete. It returns us to the home screen, and it should take my ring finger. In this scenario, we're going to go over how to reset the passcode for the keypad. In this scenario, the passcode 777777 will not work. So we are going to reset the passcode so that does unlock the safe. So you would press B on the keypad, and it would ask for a master passcode. In this scenario, it will also be 10, 10, 10. And now it will ask for a new passcode for it to be. We are going to do all sevens. The password is reset. It is saved to the ESP. And now, when we input the new passcode, it will unlock the safe. In this scenario, we're going to go over the D button feature that we implemented into our keypad. For instance, if we want to enroll our fingerprint and we do not wish to continue this process, we can press D and it will return us to the home screen. And this feature has been added to all of our modes that we added. So if, let's say I want to enroll my fingerprint and I also put in the master passcode, we are now in the process to enroll the fingerprint, but I do not want to do this anymore. It takes us back to the home screen. Same with the finger or the reset passcode. It wants me to input a passcode. I've already inputted it. I don't want to do this anymore because I remembered it. It takes us back to the main screen. And it will indicate when you're already on the home screen as well.
Here's a table of our 3 key engineering specifications, which are having a 90% accuracy rate for our fingerprint access, our email notifications being sent in under a minute 95% of the time, and lockdown mode being activated after 4 incorrect passcode attempts with the keypad.
For the fingerprint sensor, we conducted a total of 20 test runs. In the first test runs, the finger was placed in the center of the scanner to establish controlled conditions. To account for human error, we performed an additional 10 runs where the finger was intentionally placed off-center, leaning to one side, positioned in the corner, or placed completely upside down. This is fingerprint test run number 1. This is fingerprint test run number 2.
This is fingerprint test number 3.
The email notification duration will record how long it takes for the user to receive an email from our safe for various scenarios. The latest improved test run outcomes are shown in the table. The average test run time is 3 seconds, and the calculated variance is 0.45.
This is test run number 1 for email notification.
This is email notification test number 2.
This is test run number 3 of the email notification.
These are the pictures of the different email notifications the user will receive from our safe, which include email sign-up complete, Smart Safe access attempt, and lockdown mode activated. These are pictures of the additional email notifications the user will receive from our safe. First, we have the motion detection email. Then we have our stretch goal emails, which include safe door left open and tamper detection.
The following table is a summary of our 10 test runs of the lockdown mode specification. As you can see, our average percentage is 100% out of all the test runs.
This is test run number 1 for lockdown mode.
This is lockdown mode test run number 2.
This is test run number 3 for lockdown mode.
Thank you for watching our final demo video.